OBS is a bit finicky there. Okay, so we should be, we were in the middle of testing this. So, as a reminder, we've got our VR rig, and it's got this script in here, which is going to apply a force to our rocket glider's rigid body in the direction that our right hand points, times the amount that we're pressing from 0 to 1, times kind of a scaling value so it doesn't go too fast. And let's check it out in VR. And unlike in the prior lesson, or the prior segment, we're not attached to it yet. We will do that in 1 second. So you can see it moving off, lifting off into space. It's actually, I think its mass is quite a bit bigger, so that force that I was giving it, I can give it more. So this is exactly where the scalar comes into play here. So if I edit the code again under this little fly node that we've kind of scraped out and put our own stuff in, I'm gonna try making it 10 times as much, the scalar here, and then we'll take a look at that and see how fast that thing goes. Yeah, that looks fun to potentially ride around. And if I point in different directions, it can bring it back to myself. Great. So we've got a rocket glider, and we can always come in and give it kind of more force. After we kind of, what we're going to do is we're going to put a gravitational Earth and a gravitational moon in the space, and we can always come back, and if those gravities are too strong, we can give ourselves a little bit more force or kind of tune the overall experience to what we want. Great. So we just need to make the ball. Now that the ball is moving based on what my right controller says, I want the ball to tell the VR rig, the overall parent of everything in the VR space, and basically me, the VR participant, to go wherever it goes. So that's a different script. We're going to close this current one. That's the pressing script. And on the sphere, again, this is a top-level event generated by the rocket glider. Under its events, we're going to go to onMove. And onMove, again, whenever this ball moves, whenever our glider moves, we are going to tell the VR rig where to go. So we're going to drag in our VR rig, and we're going to set its position in the world, set VR, oops, I got all caps on, VR rig spelled capitalized the exact same way, colon, set world position, and this one wants a vector 3, or the object that's returned from a get world position. What world position are we going to get? We're going to get self, colon, get world position, open close parentheses. So this returns the ball, returns its world position, its center, its 0, 0, 0, and it puts that into this little function, which sets the world position of the VR rig. And let's test that out. I'll probably put some stuff I'll put some stars in next, so it's not just a black empty space, total void that we have to look at. Yes, in fact, I am moving with it, but the net effect of that is that it stays put in your view until I put some other objects into space. I'm hitting escape. I'm coming back to stop time, which it is working, which is cool. And what I'm going to do is zoom out. I'm pressing S, and I'm getting a little bit of space. I'm going to put some stars kind of in the world, which I'm going to do just with like other little spheres. And I can kind of I'm going to use the HDR on their color to make them glow, and I'll put them off in the space, and we'll change our rocket glider in a bit. And so I'm just holding down the left mouse button and moving the object around, and then just tapping Alt as I get into places, and I can kind of populate you know, a bunch of spheres out into the world. But you know what I did? I'm going to end up having to select them all here. I want to make them not move. So I need to select them all and then make their rigid body not movable. Because if we put gravitational forces or we collide with them, I want these to just sort of be, ambient in a way, like background. I'll make a few brighter than others. So I'm selecting them different. Maybe some of them are blue a little bit and glowing. That's not blue enough. Let's get over here. Not bad. Some of them are orange. I guess technically that means they're coming to or going away from. No, I didn't. Maybe I'll bring a few more of these. So now, I'll make a few more. Since these are primitives, meaning that they come from these entities and they're not like a hulking like model from from some 3D sophisticated 3D modeling software or whatever, with lots of polygons and stuff. They are fairly lightweight. We can put a few of them in the space, but yeah, we've got, you can do a little Bob Ross thing with you. Make it however you want. Make a happy little universe. Maybe there's bigger ones. Maybe a squirrel lives over here. Happy little squirrel. Okay, so now when I go into VR, I've got some background context. And maybe this stuff isn't far enough away. Maybe it needs to be much more distant, but it looks super way cooler now because I can, you can see the background and I can kind of fly through stuff, and there's this nice parallax. And this becomes really enjoyable. This is where you want to spend a rainy day. Yeah, so this is really cool. I should be able to collide with these things, but I don't think that's necessarily the intention, but at least we don't go spinning into craziness because we did that set world position as opposed to parenting. So very cool. I've kind of got this little star space. So now comes the beautiful moment of playing with the attractors, which we learned about a couple of days ago. I think day 3. And we're going to put an attractor into the space, and that's going to be the Earth, and another one going to be the Moon. And then we're going to kind of toggle with the physics and kind of blast around. And yeah, so let's put the attractor into the space. We'll stay in the physics part of things. At the very end, we're going to bring in some models from Google Poly, some Google Blocks models. But right now, we're going to finish out a few more of the kind of the physics and scripting items. And what that means is we're going to bring in the attractor and tinker with it a little bit. And so we built the attractor from scratch, so we know its contents. We did that on day 3. But today we're just going to go to physics, and we're going to place an attractor into the space. And if I press play, you'll see that the VR rig is like pulled around this object. I'm gonna actually put this on some other object. I'm gonna make the attractor be on the equivalent of like some Earth object. And this will be kind of like Le Petit Prince or something. Like he lives on a tiny planet. We'll make it like a brown, like a Mars-ish planet. In fact, we can do a little secret over here on the mesh model. We can add a little roughen and yeah, sort of kind of chunk out the mesh so it looks a little bit more. There you go. See, that kind of added a little bit of noise to our planet. And so now we have this sphere. It has a rigid body, but we're going to make it effectively not movable. I mean, we're not going to be making perfect physics. The goal of this is not for some massive physics simulation. It's more for you to have a really interesting kind of physics sandbox to experience in VR, but not that you're making like a perfect simulation of the universe. If you are able to create one of those, let us know. So we have the attract. We're going to put the attract node onto, we'll call this planet. So this sphere entity I'm going to call planet, just so we have it. Let's call it. Let's call it Earth's Z, and then we're going to put the attractor on it. And remember, it's not movable. So the rigid body on the Earth's is not. It's not movable, so it's movable false. So things are going to collide with it and kind of bounce around it, which should be kind of cool. And I want the attractor to basically be in its center, even though it's got this rough shell. I want it to be in the center. So again, to center an object on its inside of its parent or onto its parent, zero out its position relative to the parent, and that puts it in the center of the parent. There we go. Cool. Again, double clicking those little roller wheels, and you won't get to see it from that view. I guess if I rotate the VR camera, I'm not fully putting the VR on, but we're seeing from the VR perspective there. Bonk. There we go. We're kind of on the planet. Cool. So we've got this attraction here to this planet, and I'm going to make the planet a little farther off so that there's a longer journey to get to the planet when the effect begins. So I'm going to take our planet, and I'll put it here, and I'll take our put it out here. Maybe put a few stars. Put the stars kind of beyond it. Maybe add a few more. Okay. So now I'm flying kind of at this thing. And let's see if I can fly away from it. Ooh, wait. Sorry. Controller. It's not a perfect gravity-free space I'm in. Okay, so now I'm in this. So I don't have enough force to exit this gravity. So let's figure out why that is. Well, there's two forces acting on this sphere now at every frame on this sphere's rigid body. There's the one that I create from my right hand, which if I point it straight away from this sphere, I don't have enough force to overcome the other force. So if I point it straight away here, straight away from this, pointing away and like off of this sphere, I'm creating a force on my glider out and away from this object. But this attractor, also at every frame, is checking out my position and pulling me into its center. And I have both of those forces acting at once, and basically they average out, and whichever one is ultimately larger, you can think of it, kind of wins. And so how can I make myself win a little bit better? Well, that's where that scalar comes into play. And so first we're going to like play with the scalar, the amount that my, the force that I can get to get off of the planet. My force, the force that I add, and then we're also going to tinker with the actual kind of physics inside of the attractor. So let's tinker with our scalar first, and then we'll go back and check out another way of working it. I've basically created a bunch of stars. It's all these sphere entities. I'm going to clean this up a little bit as I go. You'll find me often kind of just cleaning up. I'm going to put all of these in a group. I can do that by pressing Control E. It's kind of like Photoshop in that way. I'm also going to select these other spheres and drag them into that same group. Those were created a little later. So those are all stars. So I'm just going to call this group star group. And I'm actually going to lock it, which I can select it, right click and hit lock, which means that I'm not going to be selecting, I can no longer select any of these, any of the stars or anything in that star group. It says start group. Let's be very particular. star group, relock it, unlock, relock. I can no longer select anything inside that group, but I can select our sphere, I can select the attractor under the sphere, I can select the rocket glider, so on and so forth. Cool. So I've locked that away. So let's make our sphere, let's make our glider more powerful. So the thing adding force to this comes off of that fly script that we worked on. So let's go to the VR rig, right hand, index trigger, fly, right click, edit code. And it's this number here where we were tinkering like and using it to tune. So let's actually, I like to kind of move in powers of 10 and to kind of dial it in, thinking, oh, maybe it's an order of magnitude more force. So what I'll do is just get rid of that 0 and I'll make it 0.1 and see if that's enough. Okay, so pointing away, it's working. Whoa, that's wild. I'm getting away, but as soon as I get out to here, like I'm never really escaping its gravity. But this is kind of cool. I can get into one of these orbits. Yeah, I'm now getting like kind of sucked in, and I'm in this orbit going around and around, which is really pretty spectacular. I kind of feel like this, hanging out in this kind of a environment, would give you a different intuition for space, time, and potentially even like molecular dynamics. So I'm fully pressing the right hand controller and pointing away from that sphere, but it has this code that works in such a way that kind of also scales with my distance, or stays, never has like an outer radius and never really changes too much. It doesn't work the way gravity works. It's not exactly like a gravity, which falls off at like the square of the distance. Meaning that if you can eventually escape Earth's gravity if you get up high enough. And so we're going to create something like that. And so what that means is that we need to kind of modify this attractor to kind of have a limit. And what that means is that we're going to go to the Earth, under the Earth in our hierarchy. We're going to edit the code of the attractor. And basically what we do is rewriting this a little bit. And basically what we do, Lua, if you want to square things, this actually is like, the order of operations is doing this, 1 over distance times distance, and you want to do 1 over distance times distance, correct? Mm-hmm. So this is the inverse of the square of the distance. So the distance that I am, the distance that any of the objects in the space with movable rigid bodies that are going to get a force applied to them from the attractor, it's calculating each one of them. For each of these nodes, it's doing this. It's doing this for every single one that it collects in this array. When it goes out to the space and gets all the child nodes that have a rigid body, they have a rigid body, and then it's applying this force, and it knows the distance between the two objects, and it goes, okay, if you're super far out there, like if you're out there inverse square is getting multiplied by in the final amount of impulse that's getting put on you. So when our glider, our sphere that our VR rig is riding on, gets its impulse placed on it, and its weight, and once it gets farther away, inverse square, the value calculated here, is going to drop off quite a bit more, because it's going to be distance times distance. So when it goes out, 10, it's now going to be the equivalent of 1/100th. When it goes out 100 units away, it's now going to be 1 of 100 squared, which is what, 10,000. It's going to be 1/10,000th. So it's going to drop off more, exponentially. Um, the issue with that is that things that do this, that have this inverse square thing, will get crazy forceful when you get really, really close to them, which is also a really cool property of gravity. But ultimately, you never make it to the absolute center of gravity of the Earth. You always hit some outer shell. And so you'll notice that if you create an attractor like this but don't have it sitting with an outer shell, things will come in and they'll get hyper accelerated as they get really, really close to that center. That's really fun and cool to play with, but it's not what we don't necessarily want that rocket ride happening today, and it's also like really difficult to achieve, but it's also kind of like the dynamics of a black hole, so maybe that's something fun to play with. So what we've done now is instead of this, where it's going 1 over distance, then times distance, is we're actually going to square this, which means that it's going to be much less as we go out. So that's what we want to be able to do. So we want to be able to escape. We want to be able to escape this gravity. And we might even see that the gravity isn't even enough to get us moving. I am moving though, yeah, it's definitely working, but it should start to accelerate me. I'm going to grab my controllers and show them the table behind me. Yeah, it's definitely moving. You can see a slow creep, I think. Or am I hallucinating?
No, you are.
Nope. And it's kind of picking up. But it's... I'll give it a little... No, I won't even help it. But yeah, you can see it. You can see me just gently accelerating as I get closer. There. Boom. Super cool. Potentially, I want that to be just a little bit more powerful. And so what we're going to do is we just want that force to be, to have kind of a little bit more scale to it, or to just to be a little bit big. We don't want it to scale in a different way. We just want there to be more force. When there is force, we want there to be more force. So we're just going to, we could just throw even a number in here that we don't have to vary. We can throw a number in here, like we could make it twice as powerful. I'm going to try 4 times as powerful based on what I was experiencing in there. And I don't know. I'm just searching for an effect, ultimately. Yeah, I'm going to make it quite a bit more powerful. And then I'm going to make my hand a little bit more powerful and make those kind of work against each other. So let's try this at 10. Let's see how this is. How's that look? It's not bad. It's not bad. Make it a little stronger. Let's try 100, and then let's also let's give ourselves a lot of power here, and we'll see if these two can fight it out. And by the time I get my headset on, I have arrived at Earth's. But if I point away, I don't have enough power. Oh, just wait for it. Nope. Whoa, I used the contour to blast off. Where have I gone? Oh, I escaped, but I put so much force on myself. What happened here?
Yeah,
What'd I do? I shot way out into the distance. Yeah, I need more power, right? Whoa, there. Wow. That's tough. So that's a little too much. My power is way too much. I'm going to knock my power down. On fly. Knock that back down to like sorry, not 0.1, but 0.4. and I'm gonna take the attract code down, back down to like 20. Your results may vary. I'm gonna give myself just a little less power. Yeah, definitely shot myself down here. Like curve as I fly by. Yep, boom. It snagged me. Cool, we're getting really close here to kind of what I want. I'm gonna give myself a little less. A little less force. Okay, very cool. It's getting right there. So I'm going to put a little less force on this. Knock this down to like 0.3. Tinkering, tinkering, tinkering. Able to get away. I'm getting like pulled in. Yeah, you can actually blast off. So this is awesome. Now the thing that I want to do is bring in a moon, and I also just want to change one thing here, and that is right now I'm pointing to fly. And that means that I'm like pointing my hand in a direction that I want to go, kind of like Superman like points his hand, or a magic broomstick is pointed in one direction, it goes that way. I want to do the reverse. I want to like be like pointing away from myself as if I've got like a rocket propellant in my hand. And so I'm going to actually change up the script so that you can experience it in a way where you fly in the opposite direction of where you point. So it's more like a propellant, and so the way you might do that is on our fly, we're gonna hit edit code. We're basically just gonna flip this around. So the negative, the opposite of the world look at direction where I'm pointing, I'm gonna basically say no, go the other direction, and that means we're gonna give the rigid body an impulse in the opposite direction of wherever I'm pointing, which means that I will point into the object. The right one. I'm pointing in at it and pushing away, and I can thrust kind of behind myself. And these have to be like kind of finely calibrated thrusts. Cool. So in this case, I can rock it out.
So somebody asked, Fire Warren asked, why continually take on and off the VR headset? You could just do it all inside.
Yeah, I could. Indeed.
It's a little harder just to type. I guess touch typing can be a little trickier, but
yeah, I could do it. I don't actually have to take it off. It's not my, it's not like the way that I do it, but because I can see it. If you're following along with VR, you should be able to see. You can see your Lua screen here while the headset's on, and you can see me in the background here. I'm looking at a 2D screen. It basically is rendered out in front of me, and so let's do it like that. I love it. Let me do a little challenge, see if I can make that happen. It's generally flying is about the amount that I want, and so I'm going to put one more. I'm going to put another gravitational entity in here. what I'm going to do is basically just clone this guy by holding down Alt and just dragging another one into the space. Maybe way over here, maybe up a little bit, and then I'm going to make it white. Let's make this one a little bigger. Make that more like earthen. This will be more moonin. Now I'm pushing away, so now I should be potentially caught in between the two gravities. It's funny, we've got stars in between the moon and the Earth here, but like I said, it's not going to be realistic. So I'm going to use my right button, and that blasts off. The other thing that's fascinating is that because we did this thing that like this inverse square situation, I'm now, when I'm on the surface of the Earth, I need a lot less force to get out of its gravitational pull. And so you just saw me scale it. I was like, oh, let's scale it to make the moon, let's scale the Earth's surface to make it bigger relative to the moon. What that did in effect was when I'm on the surface here, I'm now, the center of this object is like, 3 times as far as it was. So I'm now using 3 squared, I'm now using 9 times as less, I need 9 times as little force to get out of its gravitational pull. So you can see the amount that's getting depressed. I'm, at this point, not going even all the way there, and I'm able to blast off. And so what I'm going to do is now that the Earth is bigger, and this is kind of an interesting kind of dynamic, now that the Earth is bigger, I'm going to go back to its gravity. That's a copy. Let me name the copy Moon. And so on Earth, I can actually make my fly, I'll make the moon just a little bit bigger so that it is, because the moon had the same kind of dynamic as before, make it just slightly bigger, take it down a notch. So the blast off effect will take a little bit more time of the force, and then over here on the Earth, it's too easy to escape. And so what I want to do is actually knock down, I want to knock down the fly amount again. I'm gonna knock this down to like down to 0.1, and then I'm going to on the moon knock down its force a little bit as well. So this was 20. I'm just gonna make it 10.
Another cool thing we could do is scale the attraction based on the radius of the sphere. So the bigger the moon or the Earth, the stronger the attraction.
Oh yeah, sure. Exactly. So I get a blast off. That's pretty cool. That's nice. And now I'm heading in this direction. I haven't touched anything, and I'm now getting kind of pulled into the moon zone, which is cool. And then I can blast off of it. Oops. Ooh, can I? I'm moving it around. I can kind of get like a running start and kind of bounce off one of these. Yep, I got to a high enough altitude, which is kind of hilarious. But if I can use the relief of the, whoa. What? Wow. Wow, the curved flights in here is totally amazing. Oh no, it sucked me in. Very cool. I'm loving this. The experience is starting to get where I want it, and so this is the point at which you can start to like add a bunch of different planets, and eventually there might be too many planets. Every single one of them is going to be trying to run an operation, except they're really going to only be trying to run the operation on one, on each one of these is going to be running an operation, and it's only going to really find it and run it on one. So you should probably be able to do a bunch of these attractor planets in the space if you want to create kind of a whole complex. If you had, 100 things that are all floating and swirling and moving around, it might get a little heavy.
Try making the stars movable.
Let's try making the stars movable, says the technician in the booth. Yeah, let's do that. Let's see what that's like. I wanted to do one more thing, too, which is to add some propellant. Let's make the stars movable. That sounds like a total party. So we'll go back to the star group. We're going to right-click to unlock. We're going to select them all. Click the top one, hold down Shift, select the bottom one. Then we're going to go to the rigid bodies, and we're going to go movable true. And again, I did take headset off, back on. Here we go. I should get my controller. I'm going to need a defensive mechanism here. And come here, buddy. Come here. Click with my left hand. Are they moving? It scales with their mass. Did I make them movable? I'm not seeing the effect the way I expected. Oh, I know why. Because they're in the group.
That's right. You can just shift delete the group away.
And then it reparents them. The group is kind of like actually ends up being protective of the attractors. They go down and they just get the group, but the group doesn't have a rigid body, so it doesn't go down and get the children. So if I hit Shift delete away the top node, and then then I will expose all of these sphere entity copies, which are our stars. So if I Shift delete this away, I now have all of these sphere entity copies. And now, when I go into VR, everything should be... Oh, wow. What? Yeah, this is cool. This is very cool. This is like after the Big Bang or whatever. Yes. It's subtle. That's the thing that's kind of cool. Now that we kind of tuned it a little bit, and each one's a little... Like that effect of the inverse square makes these things like... Some of them are kind of caught in the middle, you see? In fact, they're sort of lining up in between them, and they're pointing at each other, which is super cool too. This is like... It's like tidal dynamics, as you can kind of see. Like the tide... The gravity of the tidal force of the moon on the Earth is pulling kind of the waters, so to speak, those spheres there, to the moon-sided face. It's just such a cool place to hang out. I love this. So, oh, there's another one kind of coming in. It took like a solid couple minutes. So you could make a game of like, you could make a game potentially of like being like a space shepherd, and these are like star sheep, and you have to like corral them onto planets or something. I'm trying to get out to this sphere, and if I can make my rocket glider sphere bonk into this one, I can maybe send it flying. It seems to be way out here. I'm afraid if it...
Yeah, you copied one way into the distance.
Really?
Uh-huh.
I don't seem to be moving anymore. Am I?
I think you are.
Oh. Oh boy, here it is. Let's get this one. It's blue too. See, there could be different points. Oh, dude, this is crazy though. That's hard movement. So, you get the idea there. That gets pretty fun. The locomotion is really pretty cool, and I I think in general too, one of the things, just as a side note on kind of locomotion, some people feel motion sickness. I get it. You don't necessarily, you kind of want to warn people that do it, but I think after some experimentation, you'll find what you do and don't like. And I don't know. This VR gives me kind of this amazing magical ability to experience flight and flying through space, and that's the stuff I want to experience. And so I'm really happy to create these kinds of experiences and share them. But they might not be for everyone. And I also have to say that this experience compared to an experience where you see the ground seems to me to give me a bit more of a motion shock. I think the fear of colliding into the ground is kind of adds an extra sense of terror, and like you can feel really off balance with that. So this is cool. We're going to be sharing, I'm going to actually just save this at this point here. We're going to be sharing this as well on Steam, so you can get in here and fly around. And the way we're going to be doing that is through, and we'll walk through it in a second, but we're going to share on Steam. And it'll upload, and we'll provide the link. The other thing that I want to do is do a little bit of propellant, and this is kind of the like icing on the cake. So we're gonna, what I mean by propellant is like, let's say I've got like a thruster, that it's the thruster that's in my hand, and it has to expel some gas, and so what I'm gonna do is create the gas, and the other thing that I wanted to do, that's maybe like another little subtle thing. You'll notice, and you saw it a couple times, when I bounced up against the side of the sphere, my camera kind of crossed the plane of these objects. The moon or the Earth, and I would then end up with this view that was like, here, I'll fly over there. I would end up with a view that was like kind of a cross-sectioned view, which if I move the camera in, this kind of view where I'm basically on the inside of the model, on the inside of the mesh, and I might want to like reduce the fact that happens. And there's a couple ways I could do that. I could put a larger like collider around me so that I don't, like, I could basically scale this thing up, my glider, so that it never really, basically so that I never get to cross that threshold. And so a way that, let me just right click and hit fly to. Basically, if I make this thing larger than me, if I scale it up like this, I might get to a place where when I collide with things, it collides out here, and it doesn't intersect me here. So what I'm going to do is actually make this large sphere around me kind of work like my protective shield. And then what I'm going to do is get rid of its material. And I should still be able to push a propellant outside of it, right? Yeah. The default material. I'm going to set this to none. And when I yeah, this is much better, basically. Like it's basically the radius that where I now feel like I'm standing on it. It may change the gravitational dynamics, and you can kind of fine tune that and find where that feels good. But that's much better, because now I won't collide and like intersect that plane and look kind of in the weird inside of stuff. So that's kind of that rigid body the rigid body of my that sphere that we just made invisible, which we call the rocket glider. It now acts as a collider that basically, like a force field that keeps me from getting in there. So I'd like to add propellant, and then I'm going to show you how to bring in some Google Blocks models to kind of like add some, like, maybe give ourselves a little rocket, or give ourselves our own spaceship or something that we're flying around. So let's add this propellant. just for fun. And the way that that's going to work is it's going to live on our hand, and then it's going to shoot out when we press. So that should be really easy. Basically, we're going to put what's called an emitter, a particle emitter. We're going to put it on our right hand. I'm just going to place it anywhere in the space, and then grab it from down here, and then while I'm holding down left mouse, scroll all the way back up and place it onto my right hand. And then while it's now here as a child with the right hand, I'm going to, you've seen us do this a couple times before, I'm going to center it onto that hand and also change its rotation, like zero out its rotation, which should have it pointing directly forward. So that look at direction, or that Z direction, that forward direction. Oh yeah, it places it up. So you're going to rotate it, I think, in the 90 degree along the X. You're going to rotate it 90 degrees forward. So 90 degrees around the X-axis is pointing forward. Yeah, the particle emitter like defaults to point upwards, and so you're going to need to kind of compensate with that to point it forward to match the direction of your hand. And if we check this out, where's my hand? Oh, come here. You can see a little bit of a particle coming out of my hand. Hands are registering together here. You can see this little puff coming out of my right hand, and it's cool and all, but that's two things. It's not the right amount of, it's not like a stream of puffs, and it's not, maybe it's not bright enough, but it's also not happening while I'm pressing. So let's do that. Basically what I want to do is get this to a value that looks correct. So I'm going to, the particle emitter has a continuous pulse, and I want to crank the frequency of that pulse. So 5 of them are coming out a second. Let's say we want like 15 to come out per second. Let's go even a little bit more. Let's try 20. Or 18 is fine. That's not bad. We could do a few more. We'll go up to 40, and then we're gonna do a special little sneaky move here. We're gonna take this up to 40. And then we're gonna basically say that this. That it's not active.
The constant pulse active.
Yeah, so we're gonna do it on the constant pulse, right? So the constant pulse basically like is either active or not, and when it's active, it's gonna give us 40 beats per second, 40 pulses per second, which is gonna make this particle emitter emit a particle, and so we're gonna basically toggle the active property of this constant pulse off and on. So by default, in the starting state, until we press anything, we're going to turn it off. And then on pressing, when we're pressing our button, which we can do right here actually in this same fly script, we can now go grab our constant pulse. We can now access our constant pulse and bring it into that script and say I got caps locks on, sorry. Constant pulse.active equals true, and then I should also turn it off on release. So I can make another event here where I want to. You'll see. Watch what happens here, and then I'll tell you what I'm going to do next. So I press play, and I press the controller. Let me press VR so you see it here in front of me. So I've pressed it on, but the thing that's happening is it's now stuck on. It's not turning off. So we need to turn it off. So how do we do that? Well, basically, when I release my my button, which means when I depress this index button, I want that to I want that to turn it off. So basically I need to have this same code and hit false, but we need to create the on release event, and I can actually just take this whole script as an example, and I'm going to copy it and paste it below itself. And I don't need this because this is not relevant. All we're working on is our propellant. Again, this is a comment with two hyphens. This code doesn't run. It's just a comment. We can organize our thing. Propellant off. Propellant on. And so basically this needs to be function node, not on pressing, but on capital R. Keep hitting caps locks. Capital R E release. On release, and then the constant pulse is the same. We go out and access that constant pulse, and we set its active property to false. So now when we start off, nothing's in our controller. I'm colliding here with Earth, and then if I press the button, out comes some thrust. And then when I release, it's gone. It's now off. So that is working the way we want it. Now I just want to kind of tune the way that it looks. So if you come to a particle emitter, there's a lot of cool things you can mess around with. The first thing we messed around with was how many things are getting pulsed, how many pulses are happening per second. We can also say how many things get emitted each time there is a pulse. Those things multiply, so this can stack up really fast to a lot of particles, and this really kind of can challenge your GPU. But I'm not gonna tell you how to live your life. The particles, they come out with a physics, so they kind of like shoot out with some velocity. You could kind of tune that. The one thing that I don't really want too much of is this randomness. I noticed that they kind of go scattering, and I kind of want this to be maybe slightly random, but not too much. They start off a little bit too faded, so I want them to not fade in so much. This is how much, like this would be fade in from 0 to 1, from completely 0 to 1. But if I just want them to come in at like full strength, I'm gonna have this down at here. Fading out is cool. I want them to be just a little bit bigger, and I don't want them to scale in necessarily. Yeah, scale in would be fine. Make them a little bigger, and then there's this moment where they get a little bit bigger, and then when they on their way out, as they die, they can kind of fade away. That's fine. I kind of like. We'll see. The main thing I wanted to do is get rid of wind. I wanted to add more per pulse, so I'm up in the like 16 range, and those are the things I wanted to tinker with, and we should kind of now have a decent thrust. Yeah, there we go. Look at that puff. Yes. Maybe the speed that they're emitted at is a little too much. Maybe I want them, because I actually generally you would have this emitter like shoot things out in a direction, but I also am moving away from them, so I might want the physics for them to like propel away from me a little less quickly, because I'm also propelling away from them, so I'm gonna like kind of dampen that a little bit. And now I'm just being a picky artist, but that's what we sort of come here for. So yeah, so you could tinker with this, sort of get it how you want it. And it's kind of cool because it also leaves this little it leaves the puff, and so you sort of see where you came from, and it kind of like can like mark out your path. Cool. Very cool. Okay, cool. So we've got this like force this propellant. Awesome. So now will be now we can like add in, you know, maybe we'll go get a rocket ship. So we're gonna go from Google Poly, and that's Google's 3D model online repository where people are sharing stuff via Creative Commons attributions license, where you're free to use them as long as you attribute them, meaning you say their name wherever you use the object. I'm going to exit VR mode to go out to the browser. I'm going to hit, and in Simmetri you can actually hit Shift, Control, and P, and you're going to get a search. You're going to get a search bar. I think is that also under Learn? No, it's under Edit. Find. Search Google Poly. Shift, Control, P. So you go to Shift, Control, P, and I'm going to say like rocket. A lot of options. We can take our pick. I'm going to. Man, interesting. This one's. Was this? Is this like the Soviet rocket? Any one will do, really. I'm going to show you a way that you can work with one. So I'm going to find one that actually is like has maybe some extra stuff. Gabriel Valdivia. It is public and it is remixable. Thank you, Gabriel. Simple rocket ship. Nice. We're going to use this one, and what I'm going to actually do is I'm going to actually get rid of the cloud of thrust here. And we're going to show you how to do that. So if it is remixable, we're going to use just download, hit the OBJ. You agree to the Creative Commons attribution. That's the BY license. Definitely learn more about that. I'm going to download it. Automatically downloads to the desktop, which I don't need to actually go and look at. I'll just go to Simmetri, and I'm going to go to File, and I'm going to use Import Optimized, which will take a Google Blocks model or another model, and it'll kind of take, if there's multiple layers to that mesh, it'll kind of package them all up, kind of collapse them into one top level unit, so you can kind of manipulate it much easier. So we're going to hit Import Optimized. We're going to go to Desktop, and on the desktop, this model is the one that we're going to bring in, but I'm going to just, because it's better this way, I'm going to teach you a different way to do it. Well, a better way to do it. Download the OBJ. When you hit download, oh, you don't give me, it doesn't give, your thing doesn't let you, okay, all right. On my partner's computer here.
You can just open dialog, rename it there.
Yeah, I'll show in folder. So what I would do is basically, this is for the Creative Commons side of things. This is kind of a key move that I will always do. I will name it rocket ship. Name it exactly. I'm going to do 2 underscores, and then I go Gabriel Valdivia. And so now I have, now wherever I use this, I know how to relate it back. So now that I've saved that, I'm going to go into Simmetri and import. I'm going to import optimized. So that's like back in Simmetri, file, import optimized, rocket ship Gabriel Valdivia, .zip. We can accept the .zip, so you don't have to do that, and it drops it in at the center of the space, and we can rename it to rocket ship. And when you have a Google Blocks model that comes in and you have some stuff that you want to get rid of, you can actually kind of edit the shape by double clicking on it, and it brings you into this little edit shape dialog where you see this gray bounding box, and I can just select some of the mesh, and it colors it pink, and I can just hit delete. Right now we don't have an undo on this feature, so basically just remember that if you want the original, you'll either have to re-import it, or if you're gonna like kind of break it apart into separate parts, which I'll often do with vehicles or things like that, and it'll break away the different moving parts of the thing. Just make a few different versions. Just clone out the object. So again, to edit shape, you double left click on it, and you get this gray bounding box, and then you can select the faces. You can also select material groups, which sometimes will give you, this is all the same material group, but sometimes you'll have a model with different materials. And you can also select individual triangles inside, but faces is going to be basically the combination of generally two triangles. So anyway, but by selecting on faces and then lasso dragging, you're going to be able to snag it all and kind of delete away chunks. And to exit this draw mode, you can either hit this button over here in the hierarchy that's like travel back up a level, or I can just double left click in the space, and now I'm back to the transform. Right, cool. So we have a rocket ship, and that's kind of some basics. We've got other tutorials online and stuff on how to do some more complex stuff with Google Models. I just wanted you to be able to kind of bring them in and manipulate them. And what I'm going to do for this one is, actually I'm going to press H to see how big humans are, because I'm going to make this one relative to it. And then I'm going to place it onto, like basically beneath the VR rig in some way. So I'm going to child it to the VR rig, take rocket ship, and I'm going to click it on its words, scroll, drag it all the way up to VR rig, and now I've got this VR rig. I'm going to collapse some of these things because you can see them. I've got rocket ship sitting on VR rig, and I'm going to now center it. But center isn't exactly how I want it. I want to make it kind of like, I want to be riding on it like a horse or something. So I'm going to rotate down. This is interesting. You notice how it's kind of it doesn't seem like it's rotating the way I would expect. Like it's not rotating in the center of the object. This will happen when you bring in these models. It doesn't necessarily know which way is up or where its exact center is. And you'll remember that I actually deleted away some stuff that was part of this. So this is reflective of where it used to have clouds and stuff like that. So this might have been an old center or an old bottom before I had all that stuff. And so I'm noticing that now as I rotate it, and I can apply something else to a Google Blocks model that I really highly encourage you. We did this to use with block models, is come in here and look at the different options for mesh modifiers. We have more lessons, like I said, online about using all of these. We used one of these to make the spheres roughened, and so this made our Earth and our Moon roughened and looking weird. We're not going to use that. We're going to use this thing called align pivot, which will this is called the pivot. You see this is literally pivoting around this point, which means the pivot's kind of another way of describing the relative center of all this mesh, the point around which the whole thing kind of pivots. So that's the coordinate center, the 0, 0, 0, the central coordinate of our rocket ship. But I need to add an align pivot, and when I do, it says take the pivot to the it looks at the data of this mesh, and it says it looks at kind of the bounding box around it, like the extent, the farthest x, the farthest y, and the farthest z. And it says in this box, if I want to go to the actual geometric center, this is where it is. If I go to the x center, the y center, and the z center, I will now end up looking like this, which is kind of cool because we just went from that kind of weird rotation to this thing that's now kind of much more intuitively rotated around its sort of geometric center. Um, anyway, so I've got this rocket ship, and I want it to be, like I said, at the center of my VR rig. I'm going to have it, let's rotate it to a sensible direction. I want it to be rotated forward, so it points forward. So I'm going to rotate it like we did with the particle emitter, kind of pointing forward. And you'll notice that this is going to be kind of strange because we're going to rotate it, and it isn't necessarily. So it's going to be kind of funny. But I'll leave you to tinker with ways to make it look cooler. And maybe in a little bonus lesson, we'll kind of tinker with this rocket ship so that this whole thing might work. And where are we positioned? We're basically, the VR rig, its height, it's like distance downward in the Y direction. Its Y position is basically where my ground is. And so this will be as if I'm standing on the rocket, which is kind of cool. I'm going to probably place it so that it looks like I'm standing on a big rocket. But what's funny is that the propellant for the rocket is not coming from the rocket, it's coming from my hand. So this is funny in that way. But bonus lesson, maybe we'll make this rocket actually fly with the propellant. So let's check this out. Go back into VR mode. And do the just pretty hilarious. I've got this like rocket ship. It's not really doing its job. I'm doing all the work here. So there you go. So that's kind of some interesting stuff to play with. So you got the physics, you've got a model in here, you've got this particle emitter, you've got on-press events, you've got three-dimensional vectors, you've got multiple gravities, you've got the inverse square on those gravity effects, you've got bodies, the planets themselves, which are not movable. You've got stars that actually are and are getting kind of pulled into the zone, getting pulled into one or the other. You've got mesh modifiers. The mesh modifier down here where we got rid of our cloud. Well, we deleted out the clouds, and then we did the mesh modifier align pivot for this guy. And then back here on planet Earth Z, we used the mesh modifier on just a basic sphere entity, and we used roughen, and we got rid of the material on that sphere that we were using called the glider, and that sphere, we got rid of its material, and it's now kind of a giant bounding sphere around us that keeps us nice and repelled from the Earth sphere, so we're just like kind of hovering here. And that's about it. We could continue playing here